Hi, in this video we are going to talk about the main differences between processes and threads. So, let's get started. It's quite important that in concurrent programming there are two basic units of execution, processes and threads. In Java we usually focus on threads. So a computer system normally has many active processes and threads, and processing time for a single core is shared among processes and threads. This is the so-called time sharing. So what's very important, that in the old times programming was sequential. We just write an algorithm in, for example, C or Pascal or whatsoever, and it's going to go on a line-by-line basis. For example, we define a variable and we set it to be 5. Then we define another variable, we set it to be 10. Then we add these numbers together and we store the value in a third variable. Of course it is 15 because 5 plus 10 is 15, and so on. This is the so-called sequential programming. But with the advent of multi-core processors, we are able to assign different tasks to different processors or different processor cores. So for example, we are able to solve sorting algorithms with the help of multiple processors, or we are able to solve the shortest path algorithm with the help of multiple processors. And the processes and threads are just the basic unit of execution. So we are able to execute a single sequential step of algorithm, for example, with the help of a process or a thread. But what's the exact difference between them? A process has a self-contained execution environment, so it has a private set of basic runtime resources. For example, each process has its own memory space. Processes can communicate. It's quite important that processes can communicate with each other. This is the so-called inter-process communication, or IPC. And IPC is used not just for communication between processes on the same system, but processes on different systems, for example, the client side and the server side. This is the inter-process communication. In Java, we are able to create a new process with the help of the process builder. But we usually use threads instead, because threads are lightweight processes. It's going to be cheaper to create threads rather than processes. So both processes and threads provide an execution environment. We are able to run, for example, a code such as adding two numbers or multiplying two numbers with the help of threads as well as with processes. But creating a new thread requires fewer resources than creating a new process, so that's why we like threads. It's very important that threads exist within a process. So every process has at least one thread. And threads share the process's resources, including memory, for example, and open files. So that's why synchronization is needed, because, for example, two threads can manipulate the same memory. For example, we store a reference to a counter, and several threads can increment the value of this counter. So that's why we have to synchronize it. We have to make it self-consistent. Or in Java applications, we have the system thread for memory management, and we have the main thread with which we can create new threads with the help of the main thread. For example, we have the main thread in a desktop application, and we are able to create a thread for downloading data from the web, or so on. So this is why threads and processes came to be able to work parallel, in the sense that, for example, the operating system have to update the main memory. It has to get rid of the unused files, for example. It has to maintain the user interface and so on. So it has to create several processes. Within a process, we have several threads, and we prefer threads because threads are lightweight processes. It's much easier to create a thread, and it's much cheaper. It's not that expensive. Of course, we have to synchronize them because several threads use the same memory, for example, or the same file. So if you are interested in command line on Windows, we are able to show all the processes with the help of the task list. You just have to open a command line and hit task list. As you can see, the operating system has several processes. Every process has a so-called PID, process ID 04404 and so on. It has a session number, and a memory usage. You can look at what's the process that's going to use most of the memory. Okay, so as you can see, we have the chrome.exe, we have the calculator, we have the application frame host, and so on. Okay, so that's all about processes and threads. Thanks for watching.